Hello. So I got the RAM module built, which is these three boards here. Above those three boards, I put in the clock, which you've seen before, and then the instruction register. Again, you've seen that before. Okay, so in the memory module, it is these two chips are the RAM. So they're 16 bytes. We can address all 16 of those bytes here through either the dip switches or through an input from the bus. Depending on, right here's how we designate which we want to do. So right now the red light's on, which it means that it's on manual. If I switch it to the green, it'll be programmatic through the bus. Since we don't have that hooked up, we'll do manual. Right here, these indicators show which address that I am on. So right now it's address 0. If I pop that up, we're now looking at address 1. Down here shows the contents of that address, right? And then I can write to the address through this dip switch here, which is switched by these two. So these two take the input from the bus or from the dip switch and then output it to the memory, which is what I'm going to do right now. So I've got a pattern. Let's put in alternating things here. So I'll do up, down, up, down, up, down, up. And then we're gonna write that to address 0. So I'm gonna hit this button and you can see that that address is written. If I go to address 1, we'll switch these. Hit the button. So now when I switch back to 0, you can see we have that, and then back is that alternating pattern. Sweet. Couple of tips, I guess. One is the data sheet and BenEater's schematics are different, or differ at least a little bit. So the 157s, the ordering, there's 4, right, switching, and the ordering on the data sheet goes 1, 2, 3, 4. If you're following BenEater's schematics, he sometimes puts the third bit or third channel, I guess, of each one on number 4, so the one up here, rather than the one down here, which kind of messed me up a little bit. So my suggestion is either go use just the data sheets for the chips and go by that, use just the schematics and go by that, or recognize ahead of time that the schematics do it not exactly in order, which honestly it doesn't matter, but it matters if you're going by the data sheet and the schematics. You wire this up by the data sheet, so the third bit is down here, and then you use part of it for the schematics, which expects the third bit here. That's when it matters. Other changes I made, I did do, number 1, I put in the Schottky dial for the clock to prevent any backwash, I guess, of signal up the clock line. So a preventative measure there. I also did the invert using this NAND chip. So the signal comes in and gets inverted from the clock right here. Gets, let's see, yeah. These two get inverted and then goes into the 157, out from the 157, gets inverted. No, it's this signal. Sorry. This signal gets goes into the 157 along with the clock and gets, when it goes out, gets inverted again before we go up to the right enable. And I think that's it. Oh, this so when I did that, I needed to switch this from, you know, being grounded on the far side to being 5 volts. This resistor, at first I had it at 10K, that did not work, so I had to switch it. I think right now it's at 2K, but that's just because what I had handy. 5K, I'm going to try that. That's probably where I'll end up, as long as that works. I think that's everything I wanted to say. All right. Thanks. Goodbye.